Hey everyone, welcome back. Professor Hank here. So today we're going to talk about the basics of package in Java. So we'll look at how to represent them in UML diagrams and how to actually implement them in Java code. So this is going to be just a brief introduction. There's a lot more than just this, but this can get us started. So let's begin. Now, when we talk about a package in Java, we're talking about something that's used to organize related things, such as classes or interfaces. And every class in Java belongs to a package. Whether you name the package or not, a class is going to belong to a package. So if you don't provide a name for your package, well then a class just belongs to the default package, right? It's kind of like an anonymous package, but it still does belong to it. It's bad practice to do that. You should always be placing your classes within a package that you name, but if you leave the name out, you're still going to be in a package. So first thing we'll do is we'll look at, the UML diagram for a package. So upper right hand corner of your screen, you see that I've already gotten started. And what I've done is I've created a UML diagram for a package named shapes. And the diagrams for these things look very similar to, like manila folder. So we've got this little tab at the top here, and that's where the name of your package goes. Your package name is going to be exactly like what you write in the tab here. So let's go ahead and start ourselves a little project, and we'll create a package with name shapes. So I'm going to go into NetBeans, going to create a new project, and I'm going to make a Java application here. Click next, and I'm going to name my project package demo. And down here in this bottom field here, you'll see there's that package field. Now I'm just going to name this shapes because it's going to agree with my UML diagram up there, right? So we'll do that. We'll click finish, and then you'll see that we've got this statement right here, package shapes. So that's how you specify that something is a member of that package. So right now we've got one class named package demo. So let's update our UML diagram to include that, right? So we've got ourselves a class, and what did we name the class? Package demo. Now this particular class has only got one method in it, and that's why we're going to leave it for this example. And that method is the public static void main method that has a single parameter, which is an array reference, and that is named args, and it's void, so it returns nothing. So let's see how that updates our diagram. Now, since main is static, we need to underline it, and that's how we designate that something is static. And let's make sure that we put that in the methods area. So there we go. So now we can see at a glance that class package demo belongs to my package named shapes. So now what we're going to do is we're going to add another class to our package. And this is going to be a class that I'll call circle. Okay, so let's diagram that. And circle is going to have a private double variable. So private double variable, which we will call radius. So radius, and it's going to be a double so we can hold floating point numbers. Now for my circle, we'll just have a few methods here. We'll include a default constructor, which we're going to call circle because your constructor has to match the name of the class, and there's no return type for constructors. We'll have a public set radius method, which will accept a single floating point number as an argument. So we're going to have to make that double, and it's going to return nothing. So the return type is going to be void because this is a mutator, not an accessor. Then we'll have an accessor method here that's also public, get radius, and it's going to accept no arguments and simply return the radius. So this is showing us that we've got, as part of our package, two classes. Okay, so let us add one more class to our package, and we'll call this class square. So we'll do class square, and square is going to have a side. So we'll include a private variable that is type double, and then we'll include a default constructor that will be used to initialize that side variable. And then we'll have a mutator for updating the side, and it's going to return nothing, so void. And then we'll have an accessor that's going to simply return the contents of that side variable. All right, so now what we have is we've got three different classes inside of our package shapes. So now let's go update the code for our program. Let's add that circle class to our package. So the way I'm going to do that is I'm going to go over here in the files section of my NetBeans, and I'm going to expand or open up the source folder here, and then main, and then Java. And then you can see there's the name of the package right there. And if I open this thing up, you'll see the package demo class. It's already in there. So what I'm going to do is I'm going to add that new class, which is class circle. So I'm going to right click on shapes, select new, and then Java class. And so here I'm going to specify the name of the class, which is circle. And you can see that the package is already filled in, that package field shapes. So when I then hit finish, that's going to add a new class. You can see that it's right there in the same subfolder. You can also see that we've got that package shapes statement. And so this indicates that class circle is part of my package. So let's implement circle. So what did we have? We had a private double variable named radius. We had a public constructor named circle, and it's a default constructor, so no parameters in its parameter list. And we're simply going to initialize radius to 0. And then we're going to include that mutator, which is also public, and its return type is void, set radius, and its parameter list is going to be a single parameter that is going to be named R, and it's going to be a double. And then we're just going to set the radius to the argument. And then we're going to have our accessor method getRadius, which is going to return the radius, this.radius. Okay, so we've just added that class to our package. We've implemented it. So now let's go and add the square in as well. We're going to go back and do exactly what we did before. And we're going to right click on the name of the package, do new, Java class, and we're going to name this square. And you can see that it's part of package shapes. And we'll hit finish. That'll create our new package. I'm gonna get rid of this stuff here and we'll flesh this thing out. Now notice here that this says public. Okay, so I have one class in my file here. It's class square. It has to be public. And you'll also notice that the name of the file is square.java, right? It's square. So these have to agree. The name of the class and the name of the file have to agree. And the class that shares the name with the file has to be public. So let us then do our private double side, and then we'll add our constructor, public square. It's going to do the same thing. This dot side equals 0, and then we'll have our accessor and our mutator. So we'll do public void set side, and we named that parameter S for side. So that's a double also, double S. And we're just going to update this dot side to be what the argument is, and then we're going to have our getter. So public double get side, our accessor here, which is going to return this dot side. Okay, so now save that, and we've added all those classes. So you can see, I mean, physically it's laid out here. We've got 3 classes, part of package shapes here. Okay, now if you were to look on your hard drive, if you were to go through and use your Finder or your Windows Explorer, you'd go and find actual folders, directories that correspond to that in your project folder. Okay, so you can see that I have opened up my Windows Explorer and I've opened up the folder for this project, and you can see that it corresponds to the file structure under the files area in NetBeans. So if I open up source and then open up main and then Java and then shapes, you can see there are the 3 source code files. So it literally corresponds to actual locations within the project. Let's go back to packagedemo.java and let's instantiate instances of each of those classes. So I can do circle C equals new circle, and that's going to create a circle object. And then I'll do square S equals new square, and that's going to instantiate a new square. And then I can start invoking its public stuff. So I can do something like s.setSide, and I'll set it to like 1.1. And then I could do something like c.setRadius, and I'll do something like 3.2. Now notice that the classes, they're not defined in the same file this time. They're in the same package, so I can instantiate them. I can use those classes because they're in the same package, but they're in their own separate files. And this is kind of the normal way of doing it. Normally you want to have one class per file. Now, if I wanted to retrieve those values from those objects, I could print them out. I could put them on the screen by doing system.out.println, and then maybe doing something like c.getRadius. And then if we run that, you're going to see that the values were in fact stored. So we'll see the output here when this finishes. All right, so you can see it down here. There's the 3.2. All right, so now is a good time to mention the package level access. So in my UML diagrams, you can see that I've got everything labeled with either private or public, but we also have something known as package access. If we were to leave an access specifier off like we did here with radius, then that indicates that we should have package access. So what does that mean? That means that any class within the same package has direct access to that attribute. So let's go update our circle class to reflect that change. We take away that private attribute. We take away that private access specifier and save that. Now this right here now has package level access, So if I go back to my main and I want to directly access the circle's radius variable, I can do that. So I can do something like system.out.println c.radius, and it's not going to complain because since packagedemo.java and circle.java are in the same class, then packagedemo can directly access that radius variable in class circle because that radius variable now has package level access, which is the default. If you don't indicate private, public, protected, then that's the default, but that's generally a bad idea. I mean, you only want to give other classes direct access to your stuff if you have a really, really good reason. So we're going to go back and make that private once again. And you can see how now we got the red squiggle. This isn't going to compile because since it's private, we can't directly access its stuff anymore. Now I want to show you a couple of other things in this video. Let's go back and update our UML diagram since radius is now private again. So what I'm going to do is I'm going to add a method to my square. So I'm going to do something like this. I'm going to say plus to make it public, and I'm going to do something like is less than. Okay, I'm going to make this method, and this is going to be how we're going to be able to compare one square against the other. And in my parameter list here, what I'm going to do is I'm going to name my parameter as always. So I'll do something like s for square, but the data type for this is going to be another square. So you can pass an object as an argument to a method. And what I'm going to return here is going to be Boolean. This is how I'm going to compare them. So what I'm going to be able to do is I'm going to be able to determine whether or not this square is less than some other square. And we'll see what that looks like. So let's go back into our code and update square.java and add that method public Boolean is less than. And in our parameter list, we're going to do another square, and we named it s, I believe. And so here inside of this method, we're going to define what it means for one square to be less than another square. So we're going to compare this square's side against the argument square's side. So we're just going to ask it to return that side value. Now notice that we're not being able to do s.side because the side is private. So we're using get side, okay? And then since the less than evaluates to true or false, which is a Boolean, I can simply have a return statement that will return that. So now let's go and create another square. So I'll go ahead and delete this stuff, and we'll do something like square s1 equals new square. And we'll ask the user to enter the values for the squares. So we're going to have a scanner object. So we'll do java.util.scanner, and we will add a scanner here. So scanner input equals new scanner, and we're reading from the console, and then we'll ask the user for 2 squares worth of data. So we'll do something like system.out.print, enter the side for square 1, and then we will read that into a variable. So we'll do something like double num equals input dot next double. Then we'll assign that value to the first square. So we'll do something like s dot set side num, and then we're going to have to move these guys up to the top here to make sure that everything's in scope. So we'll do that, and then we'll ask for the second one, and we'll do it slightly differently, just to show you that you can do things in a lot of different ways. So enter the side for square 2, and this time what we'll do is we will do s1.setSide, but I won't create another variable here. What I'll do is I'll just take what's returned by the next double method, and I'll just pass it as an argument directly to set side. So we'll just do something like this, input dot next double. Now, once I have those values read in, I can invoke that is less than method as part of a test expression. So I could do something like this. I could say, well, if s dot is less than, and I'll pass as an argument s1, then I will have a output statement that just says, oh yeah, this is less than. We'll do something like system.out.println, the first square is less than the second. Something like that. Okay, so this is how we can do comparison between objects. We just create a method that is going to take another object as an argument, and then we'll include logic that is going to define what it means for one to be less than the other. So in this case, what we're doing is we're invoking s's is less than. I guess you could say more precisely, the object whose memory address is in S, that object is less than, and then we're passing to it as an argument the memory address of a second object that is being stored, that memory address that's being stored in S1 here. And then we're asking that second object to give us its side, and then we're going to compare it against our own. Right? So let's go ahead and test that now. So we will run this. Right? So the first side for the first square is going to be 1.1. The second side for the second square is going to be 3.3. And we're going to see that it is true that the first square is less than the second, because the first square contains 1.1 and the second square contains 3.3. Now we'll test another case. So let's have the first square have a bigger value, 5.2, and the second square is going to have 3.8. So now we don't see anything because 5.2 is not less than 3.8. All right, so let's look at one more thing here. Let's implement a toString method for our square. So we will add a public toString method, which is going to return a string. So what we're going to do is we're going to have this method return a string representation of a square. So you can define whatever that means for your project. We're just going to have it return side as a string. So we will do something like this. We'll do public string toString, and we'll use our string wrapper class, and we'll invoke its value of method, and we'll pass it this dot side. And then we're just going to return that. And so the cool thing about that is it allows us to build strings without having to do any extra work, right? Even though we created this class, this data type, this square ourselves. So let's go back to our main method, and we'll change our out statement right here, right? Our system.out.println. We'll do something like this. We'll build it. We'll say s plus is less than plus S1. So what this does is this causes the toString method to be automatically invoked. And so how did we define that toString method? Well, what it does is it creates a string version of what's inside of this side and returns it. So what we're actually doing is we're actually using string concatenation all along here. We're doing it for the first instance of our square and for the second instance. And you know what, let's do an else here. We'll do a else, and we'll do a system out down here, and we'll say is not less than. Okay, so in this way, we're using the toString method to display the contents of that side variable. Okay, so let's go ahead and test it. All right, so enter the side for square 1, we'll do 1.3. Enter the side for square 2, we'll do 1.3. And so you can see 1.3 is not less than 1.3. Why? Because when we pass 1.3 into the first square, the 1.3 into the second square, both of their sides held 1.3. And so is 1.3 less than 1.3? No, that's false. So that false was returned right here. And then that evaluated to false, which means that the first part of the if statement was skipped, and we jumped down to the second part, and we saw that 1.3 is not less than 1.3 because the toString method returned a string representation of 1.3, had concatenated to it, is not less than, and then to that we added the 1.3 here. So let's do one more example, and then we are out of here. So one more test. So this time we'll do something like 0.87 for the first square. And then for the second square, we'll do 3.14159, and we'll examine the output. So we can see here that we've got 0.87 is less than 3.14159. That's true. The toString method produced this for our first square. toString method produced this for our second square. The is less than method returned true because 0.87 is less than 3.14159. And since that happened, that true was returned right here and caused this test expression to evaluate the true, which caused this system out statement to execute, bypassing this one. Now, if you wanted to, if it made you more comfortable, you could put a double equals in here and explicitly compare them. That's fine, you can, but it's not necessary. So this is our final version of our package demo.java for this example. Here is our circle.java, and here is our square.java. And also notice on the left-hand side, that this file structure agreed with what File Explorer or your Finder, if you're on a Mac, will show you. And this is the name of our package, and all three classes belong to that same package. And we specify that in the code by having this package shapes statement. And notice that the class name agrees with the file names. So circle, circle, square, square. And also the class whose name agrees with the file has to be public. And finally, if you leave an access specifier off, then that is an example of package access. And in your UML diagram, that just means that you're leaving off anything in front of the attribute for the class. So now you know some of the fundamentals of packages in Java. As usual, if you're a student of mine, you have questions about any of the content in this video or any of the other videos from our course, feel free to email me via Canvas or stop by my Zoom office hours. Thanks for watching, and we'll see you next time.